This lesson will be on sketching the graph of a polynomial function. Alright, the first thing that I want to talk about is the definition of a polynomial function, or basically a way to identify if something is a polynomial. Alright, so polynomial functions, they look like this. So the f of x is equal to 3x minus 2. G of x is equal to 3x squared minus 4x minus 6. And h of x is equal to x to the 4th plus 5x cubed. And we could just keep going on and on and on with this. Something like this. The degree of each of these functions, so I'll just make a little table here, degree. Hopefully you've already gone over this or remember it from a previous lesson, but the highest power, exponential power here is in f of x equals 3x minus 2. Is this x to the first power. So this one has a degree of 1. This one, it has an x to the with a degree of 1 and an x with a degree of 2. The 2, I call it the boss. So it's the highest power is going to be the boss. So this is the a second degree polynomial, and then this one is going to be a fourth degree polynomial. The reason the degree is important is because when you're asked to sketch the graph, actually, first let's talk about the difference between sketching and graphing. The difference between sketching and graphing. When you're asked to graph a function, generally what they're asking for is something that is very exact. So you're probably going to want to use graphing paper. Alright, so like I was saying, you're going to have to probably going to want to use some graphing paper. And then they're going to give you some function. Let's say f of x equals x squared. So you're going to fill in a table of values. So let's go -2, -1, 0, 1, and 2. And if I input -2 into this function, I get the f of -2 is equal to -2 squared. Negative times negative is positive. 2 times 2 is 4. So this one is going to be 4. And likewise, I would do this for the rest of them, and I would get 1, 0, 1, and 4. So, like I said, there's a difference between sketching and graphing. When you're asked to graph something, you're going to want to plot points. You're going to want to use some accurate measurement between the values. Even if you were to hand draw it, you would want it to really just try to be as specific as you possibly can. The way that I kind of think about it is that graphing is more exact. So imagine if you had a picture of somebody in your hand and you were to hold it way out in front of you, or maybe across the room and you're looking at it from across the room. That would be a sketch to me. It's like I can kind of make out things that are going on. I get the general gist, whether it's a man, a woman, a flower, or whatever. But I don't really, I don't know all the intrinsic nature of what's going on inside the picture. Now, if you take the same picture and you hold it up close to you and you're looking at this picture, you can make out all kinds of details. You know what the person looks like. You probably know what color their eyes are, or how many petals are on the flower, or what's on the ground next to the flower. So that's kind of like the difference between sketching and graphing. Graphing is more exact. Sketching is just a rough sketch, if you will. Okay, so we're going to actually plot points here. So at 0, it's 0. At -1, it is 1. At 1, it is 1. At 2, it is 4. and at -2 it is 4. And you might want to go as far as to label your points. So this will be the point 2, 4. This is a point 1, 1. That doesn't look very good, but whatever. We get the point. And then you want to go through and just connect the dots. Starts up here somewhere, goes through these points. You have to pardon me, I'm using an electronic pen, and it really takes some getting used to. But imagine for a moment that all of those points ran through. As a matter of fact, let us look at this from this perspective. So if we go, this is a TI-84 Plus. Should be similar to what most of you are using. If you're using something else, that's fine. Large screen. Okay, so this is what the graph of x squared looks like, and it kind of looks like that. And if we wanted a prettier picture, let's see if we can't get a prettier picture of what x squared would look like. There we go. So let's go ahead and trace this. And we'll go over here to 1. And you can see at 1, it's at 1, and at 2, I guess that's as far as it's going to let me go over. So if we zoom out, we can see that this function, goes to positive infinity on both sides. So this would be graphing, and we're not graphing, but I wanted you to be able to see the distinct difference between the two. So let's look at what a sketch would look like. To sketch a graph, it's going to be a lot less specific. We're going to want to know the zeros of the function. So when when y is 0, we get the x-intercepts, and when x is 0, we get the y-intercepts. That's kind of ugly, isn't it? Okay, so y is 0, and x is 0. Again, that should just be a review, but let's talk about what it means to be a 0. If you are a 0, let's go back and drop in some graphing paper here. If you are a 0, it means that you cross the x-axis. So if x plus 3, x minus 2, x equals 0. So we had x plus 3 equals 0, we had an x equals 0, and we had an x minus 2 equals 0. For the y-intercepts, it's when the function, when the x is 0. So if I was graphing, these are of course all just zeros, but something like x squared, and I was to sketch this graph, and I wanted to know what are the zeros of this function. Well, I would take x squared and set it equal to 0, and when y is 0, x is 0, and when x is 0, y is 0. So what that means is we can do a rough sketch of what the graph might look like. I like to call them parent functions. So the parent function here of x squared is x squared. And I know that my 0 runs through this point right here, and I know it's parabolic in shape, which means that it's going to look something like that. And I might want to go in here and label my axes. So I might label that my Y, label that my X. I'm really not going to put any points on here. I mean, I might, you could say this is 0, 0, but it's not necessarily necessary. And I might want to make this actually touch it a little better. But all of your squared functions are gonna have this look and this shape. So graphing something like x to the fourth. So y equals x to the fourth, and let's graph it right on top of this thing. What it's going to do is it's going to be more tubbed out. And actually, let's look at it from this perspective. We'll go here, and so this is the x squared graph in red, and this is the let's zoom in so we can really see what's going on here. Do you see how this is more tubbed out? Let's go x to the sixth and graph that in pink. You see how it's getting more tubbed out, more tubbed out? Anyway, when you're sketching a graph, it's really probably not necessarily important to show that, but so long as you have a general idea of what's going on there. And I'll talk about that in a minute. Let's look at cube functions. So we have y equals x cubed. So we're going to draw our axis again. So just bring it in here, and we're going to do just a rough sketch of what x cubed might look like. And it's zeros. It has 3 zeros, but they're all 0. So we have x cubed equals 0, and then this is literally x equals 0, x equals 0, and x equals 0. So we have 3 zeros right there. That's probably a bad color. And basically the cube function kind of looks something like that. Passes through that point, goes up. Again, this is a sketch. It's not accurate. If I wanted to get really accurate, I come over here and I make a table of values, and I say, okay, well, what happens when my x is -1, 0, and 1. So at -1 it's going to be -1, and at 0 it's going to be 0, and at 1 it's going to be +1. So 1 it's +1, at 0 it's 0, and at 1 it is, or I'm sorry, at -1 it's -1. Okay, so my graph is a little off. It should have went something like this. But again, it's a sketch. That's it. I was just sketching it, and it was fairly accurate. Okay. So for future, maybe we always even though it's a sketch, maybe we always go, okay, 1, -1, 1, 0, and 1, something like that. All right, let's go ahead and clear this. And we'll scroll back up. Okay, so we've talked about a couple different functions, but I'm going to go even one step further. We talked about f of x equals x squared, and we talked about f of x equals x cubed. Interestingly enough, these are going to be your even functions. And all of your even functions are going to have this up to negative infinity. It's going to come in from negative infinity, and they're going to go to negative infinity on the right. All of these functions are going to come from, we're going to go down here and up here. What happens in the middle, I really don't care about. Not yet. I just wanted you guys to get the basic idea that parabolas and even functions, and these are odd functions. So we have parabolic and cubic functions. That's what I call them. Even and odd functions. It's probably more appropriate. Okay, so we have an even and odd function. So if I just ask you, maybe, let's look at f of x equals, and we'll just call all of these f of x. So if I say f of x equals, get my pen going here. Sorry, my pen stopped working. Okay, so f of x equals x squared, x to the 5th, x to the 4th, and x to the 122nd power. And maybe we go a little further. Maybe we say that x cubed plus x squared plus 5, x to the 4th plus x squared plus 2, x squared plus x to the 4th minus 5x, something like this. Then I'm going to switch over to red here. And all I want to know is x squared an even or an odd function? And if you said even, you're right. X to the 5th, is this an even or odd function? If you said odd, you're right. X to the 4th, even. X to the 122nd, even. X cubed plus x squared plus 5. Okay, now we have, like, these were pretty simple. But what we need to look at is the highest degree in the polynomial. So what I'm going to do is I'm going to circle it. 3 is bigger than 2, right? So is this an even or an odd function? If you said odd, good job. This function here, which one is higher, 4 or 2? Well, it's 4. So it's going to be even or odd. You got it, even. This guy. Well, I tried to trick you here, didn't I? Intuitively, you should be saying, okay, that's a 2 and that's a 4. Well, most times they will write them in ascending or descending order. So technically, if I was writing this, it might be more appropriate to write it that way. They mean the same thing. There is no difference really, other than, you know, how I wrote it. So don't let them fool you when you get to a test situation. You're looking for the highest degree of the polynomial, no matter where it is in the polynomial. So so this is to the 4th power. So is this going to be even or odd? And if you said odd or even, good job. All right. Now we're going to use these functions, and we're going to do some quick sketches of them. Matter of fact, let's just do it right over here like this. Okay, so this is x squared. So here's my quick sketch of x squared. That's a terrible sketch, Jason. Alright, so we go up to infinity. Okay, something like that. And this guy goes with this guy. X to the 5th. It's an odd function. Something like that. X to the 4th. Something like that. Close enough. Let me put this is x to the fifth, x to the fourth. This was x squared. X to the 122nd power. 122nd power. Well, you know, to be honest, I think that's gonna. It's probably gonna. It's gonna be more tubbed out, like a lot. It's probably gonna come down and do one of those. I don't know. We'll look at that on the actual calculator. Matter of fact, let's do that. Let's use the calculator here. So what if, let's turn all of these off. We change this to 122 and we say, graph that baby. Yeah, see? See what I mean? Let's zoom in. And it won't even show it to me. And I mean, this is literally because there's 122 zeros, and if you were to trace it, look at all these zeros. If you look down here, you can see 0.125, 0, 0. And you know, it's not that they're zero, it's that they're so close to zero that this graphing calculator here has literally like rounded them, I guess. I don't know. Anyway. So comparing this to x squared, just one more time here. So that's the graph of x squared. This is the graph of x to the 6th, this pink one. Again, see the bottom, more tubbed out. I'm just really trying to hammer this home. And this is x to the 4th, a little less tubbed out. Now watch what happens when I zoom out. Now look, this is 2. This is 4, and this is 6, x to the 6th. Notice that the third power one isn't shown. But when I zoom out, look what's happening at the end of this thing. Do you see how this up here, right here, and here, going off to positive infinity on both sides? So that's going to become paramount in your ability to graph these guys. All right. Again, like I said, we're just sketching here. Alright, so here we have, I probably shouldn't graph these, or I should have picked better functions, because I want nice zeros. So what I'm actually going to do is I'm going to skip that for right this second, and I'm going to write a nicer one. So that'll be easier to graph, and I won't have to do a whole bunch of math. Okay, so what if f of x equals, and I'm just going to make my own zeros, x minus 1, x plus 1, and x plus 2. So these are my, this is my function. Notice that if I multiplied everything out, and I'm really only concerned with this first term, because that will tell me the degree of the entire polynomial. So we have x times x times x. Well, that's x cubed. Okay, so the degree of this polynomial is 3. 3 is an odd number, so this function is an odd function. The parent function is going to be x cubed. And like all this other stuff, of course, it's going to be x cubed, da 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 da, plus x squared, plus x, or something of that nature. But it's going to have this general shape that goes down to negative infinity and up to positive infinity. And then somewhere in the middle, it's going to do something. Something in here. But see, what I know now is I know that I can come up from this side and I can go off from this side. So check this out. Let's go with black. Okay, so we have our axis. I'm going to label it my x and y, and I'm I'm going to grab some colors here, and we'll go with, so this is going to be 1, 2, 3, -1, -2, -3. So my zeros are going to be x minus 1 is 0, so 1. My next 0 is going to be, I'm sorry, it actually should be -1, comma 1, comma, and then -2. And all I did was set each of these to 0. I said x minus 1 equals 0, x equals 1. X plus 1 equals 0, x equals -1. X plus 2 equals 0, x equals -2. And I'm trying to be clear because I hate it when I'm trying to watch a video for somebody and they do something and then they don't explain it, and it'll be the one thing that I don't know that I need them to explain. So, okay, so it's going to be x is -2. When x is -2, we get a 0. -1, we get another 0. And at 1, we get a 0. Now, so far this is what I know. I know from this picture and the parent function that it's going to have to come from this lower left quadrant. So we have quadrant 1, 2, 3, and 4. If you didn't know that, so I know it's going to have to go to -infinity from quadrant 3. I know that from this picture over here that we're going to have to go to positive infinity in quadrant 1. And I'm trying to explain this from a very intuitive manner, so that way you can do all of them pretty easily. Okay, so this is what I know. Now look at this circle. You see this circle here? That circle is basically what I don't know. What else do I need here? Let's get a y-intercept. Y-intercepts mean that it's going to cross the y-axis, right? Okay, so that means that x has to be 0 to get this y-intercept. So we have y is equal to 0 minus 1 is -1 times 0 plus 1, positive 1, 0 plus 2, so positive 2. Okay, so this is -1 times 1 is -1. Negative times positive is negative. Okay, so we have a y-intercept right here. I'll put this in pink. That's my y-intercept right there. I'll even make this pink so it corresponds. It's going to be color coordinated. Okay, so remember what I said was that the stuff that goes on in the middle here we weren't concerned with. Like I didn't care. All I wanted to know was what it was doing at the end. That's what the odd function tells me. Odd function tells me what it does at the far ends of the graph. So this is what I don't know. I figured out what happens when we get inside this little green circle over here. I know what happens. It crosses the x-axis and it crosses the y-axis somewhere. And I've marked those here. So now I can sketch this graph. Okay, so at -2, I mean the graph has to go through -2. Would you agree? The height here I don't know, and you won't know until you get to calculus. So we're going to skip it. We don't care. I know that it has to go through this 0. It's just like connecting the dots, really. I know that it has to cross this y-intercept. It has to go through this 0 off into infinity. Well, look at that. That's a sketch of this graph. And it was just that simple. So what did we do? We found the degree of the polynomial. We found the zeros of the polynomial. We found, which are going to be the x-intercepts and y-intercepts. So we found the zeros or x-intercepts and y-intercepts. And we looked at the parent function from the degree, and that probably isn't like technical mathematic language, but it's what I like to call it, and it's what the way that I personally have memorized it, and I kind of like, it's like, you know, your parent, you take after your parents. If your parent function is cubic, then you're probably going to turn out to be a cubic function. So okay, so that was the cubic function of the third degree. So let's look at our sketch, and then let's go over here to this graph, and I hope graph does what I want it to do here. So we have x minus 1, x plus 1, and then what's it, x plus 1, x plus 2. And then it's going to be red, and we'll zoom in. And we'll show that, and we'll hit graph. Okay, let's compare. So this is what the graph looks like. Notice that it comes from negative infinity, goes through the point negative 2, goes up to some point. This is the point we didn't know. Goes through the point negative 1, comes down, crosses the y-axis, and again, look at that, look at that. See, I didn't know. Like, look at my sketch. Look at my sketch. See how I said it happened? That's not really the way that it happened. But again, it's a sketch. Where were we? Here. I was trying to move it around so I could see. Oh well, I'm not going to fool it. But anyway, they look about the same, right? One more time. If I could copy it. Oh well. Okay, let's move on, and we'll graph another function. Let's say we'll graph another cubic function, or where the parent would be cubic. I'm going to try to speed this up just a little bit here. So let's say we had some zeros. X minus 3, x plus 1, x minus 2. Let's say that was my function. Why don't you take a minute, try to do a graph, and to give you a little hint here, you need to fill in this. So you need your x-intercepts, you need a y-intercept, you need, let's say, the degree, and is it even or odd? And over here, just make a little crosshair and draw the graph of the parent function. And go ahead and pause it and try that. And when you come back, we'll go over it. Alright, so hopefully you took the time to do that. I always say that math is not a spectator sport. It'd be like sitting in the bleachers watching a football game, thinking that because you're watching the game, you're getting better with the game, or you're going to be anyway, I think you get the point. Okay, so the x-intercepts are going to be where y is 0. So this is going to be, let's see, 3, a negative 1, and a positive 2. Let's draw this right here. So at 2, negative 1, and 3. When this is 0, we get -3. We're doing the y-intercept now. When this is 0, this becomes 1. When this is 0, this is -2. So I have -3 times 1 is -3. Negative times negative is positive. 3 times 2 is 6. So we have a positive 6 for a y-intercept. Alright. So we got 1, 2, 3, 4, 5, 6. And we need, that's pretty much it. So we got this one, -1, 2, and 3. That should be. All right. The degree of the polynomial. Should have said it's a degree 3. Remember, that's x times x times x. If this had been squared, it'd be x squared times x times x. Is it even or is it odd? Well, that's a third degree polynomial, so it's going to be odd. And, oh yeah, I said to do a rough sketch, you know, what's going on here. Remember that it's odd, so its parent function is x cubed, and again, this one just so happens to be x cubed. I probably should have added another 0, or 2, I mean. Alright, so what does the graph do here? We're going to come from here, off to infinity there, and so we come, trying to grab another color. I wish this program was more color friendly, but it's not. Alright, so we have to go through the point 1. Actually, this might be better. Through 6, down through 2, up through 3, off to infinity. So pay attention to that red line, not this line. It's probably going to look a little better than what I've drawn it. Again, this marker here, this E pen makes it hard sometimes, especially when you're whatever. That line is supposed to look like that, just so you know. Supposed to, you know, be fluid. I can't get my pen to do what I want it to do. Okay, so that was x minus 3. So x minus 3, x plus 1, x minus 2. Make sure that's right. Yep, x minus 2. And we'll look and see what this one looks like. And let's see there. Boom. And we'll zoom out. Okay, so see how it went up through -1, which we had. It went through the y-intercept of 6, came through 2, went down again. Remember, notice, see how close it is? See, that I won't know. We won't know until you get to calculus. This pen to work here. So again, this is what they had. What they had was something like that. Notice that mine comes down. It doesn't matter. It's okay. Right? Just as long as you're showing that it's going down here somewhere and going back up, we're good. Let's draw a little smiley face there. All right. Let's look back at this graph. Okay, so we came through here. We went back up through 3, and look at that. It's the same cubic shape. So let's add a value. What if I added x plus 5? And I hit graph. What do you think is going to happen? or let me rephrase. What do you think the parent function is? So what I'll do here is I'm going to unlock these two, and we're going to say this is x squared, this is x cubed. So the green one, oops, and okay, so we have the green one and the blue one. The green one, and actually let's change that to something a little brighter. Okay, looks like that's all we can get. So the green one is cubic. The blue one is parabolic because its parent function is x squared. Or it is x squared. And again, this is I'm getting ready to try to show you why I call this a parent function. Okay, so look here. We have x times x times x times x. That's x to the fourth power. That's going to be an even function. If it's an even function, its parent function is this blue function. So I bet you that this graph here, this y1, is going to have the same shape. It's going to be up here and up here. All right, so let's hit graph. It's going to be the red one. Here it comes. Where is it? Oh, I clicked. Sorry. Here it is, the red one. So let's zoom out to see what it does. That's interesting. Okay. I wonder how to change the oh, here we go. So let's say on my x-axis, I want to take that out some. So let's go something like that. And take my y-axis. Something like that. And then we'll zoom in from here. Well, there it is. It's not showing me. And you know what it is? It's because this value is way down here. Look how far down that value went. All the way down here. Let's look at a standard window. What's a standard window? Okay. But again, well, notice over here, this went up to infinity, and this one, or negative infinity, and this one goes up to positive infinity. So the thing, it came down, it came up, it came down, and it went back up. Let's try to make this, let's say, x to the fourth power plus 7x squared minus 4, something like that. Look at that. So it's parabolic. See the red one? Now let's take this and let's multiply this by x to the second power. And if I do that, it's still going to be a its parent function. It's still going to be an even function because I'm multiplying it by x squared. Well, this program's not going to let me do that, is it? Oh, I see why. See, those parentheses are right there. There it is. Look at that. It's still parabolic, right? Okay, so what if I was to multiply it by x? Now it's going to become a cubic function. Look at that. Down to infinity, up from negative infinity, and up to positive infinity. All right. Go ahead and clear this canvas. Let's here. Okay. So let's now look at something like f of x equals x plus 2 to the second power times x minus 4 to the third power times x, just x. Okay, so we need to find x-intercepts, y-intercepts, the degree, and is it even or odd? What the parent function looks like. Don't care what happens in the middle. And let's see. So we have our, I'm going to introduce a new term here. So for our x-intercepts, we have zeros, and I'm going to introduce something called multiplicity. And we'll talk about that in a minute. Okay, so I have x's at -2 with a multiplicity of 2. Watch what I'm going to do here. Because it's squared. Because this, what this means is I have x plus 2 times x plus 2, right? That's what this means, right? All right. Let's see. I have x's at 4, or zeros at 4, with a multiplicity of, you guessed it, hopefully you said 3, and then we have x equals 0, so 0. Oh, sorry, I didn't mean to do that. What is the multiplicity for x? It happens one time. So if you said 1, you're absolutely right. Alright, so what is the degree of the polynomial? Well, if I multiplied these guys out, I would get x squared. If I multiplied the x minus 4 out, I would get x times x, which is x squared times x, so sx cubed, and then just x. So I have, how many x's do I have? 3, 4, 5, 6. So this is x to the 6th. So the parent function, sorry, my pen, I keep hitting the little button. The parent function is x squared. So it's going to be parabolic. So it's going to take on this shape. Okay? I want to introduce something else here. Sometimes they want to talk about peaks and valleys. So, real quick, before we graph this function, let's look at x to the 4th. That was this guy. And let's look at something like what we had before, the x minus 3, x plus 2, x minus 4. Something like that. I'm just going to real quick go through this. So I have zeros at 3, a 0 at -2, and a 0 at 4. Right? Okay. This is x times x times x, so this is cubic. And since this is, so let me just make this x cubed, and let me just say this is f of x equals x to the 4th. Because this probably isn't going to make sense at first. And that's okay. but we're going to talk about it. Okay, so the function, when you graph it, this is cubic, so we know it's going to come up here, it's going to cross the y-axis, it's got to go through this, and it's going to come back up, right? Now, the peaks are these points where, grab some red, there's a peak, there's a valley. Now notice this has one peak and one valley. So if I total them up, so this has peaks of 1 and a valley of 1. When I total those up, I get 2. What they say is that the function minus 1 is equal to the number of peaks and valleys. Or let's rephrase this, because it's not equal to the number of peaks and valleys. It's equal to the number of maximum peaks and valleys. The max number of peaks and valleys. Yeah, let's say that. That could be there. I think it's intuitive, but it's only going to be intuitive. Like once you get a little further along in mathematics, that'll make a whole lot of sense, but it'll also make a whole lot of not sense. Because look at this one. This is x to the 4th, right? I mean, this is its graph. That's a sketch of its graph. Its actual graph looks like this. So it's going to be the green one. Alright, so looking at this is where it gets tubbed out. How many peaks? How many valleys? Well, I only see 1. Well, I thought you said that x to the 4 minus 1 is equal to the maximum number of valleys. Not happy right now. That's what I said. This would mean that it should have 3, right? I mean, there should be 3, but there's not. And here's why. Going up here to this function, we're going to go ahead and graph this. Okay, so I'm going to try to graph this baby. We'll go, okay, our zeros and our multiplicity, I'm looking right here. So we had -2, 4, and 0. Grab a new color here. We said that its parent function was x to the 6th, or I'm sorry, x squared. So it's going to have this end behavior. I think I might have introduced a new word for you. This is what happens at the end of the graph. Remember, I don't care what happens in the middle. I figured that out through zeros and y-intercepts. Did we figure out a y-intercept? No. So we're going to have 2 times -4. Actually, I'm sorry. This is going to be, I'm going to write it out. This is going to be 2 squared times -4 cubed times 0. So it becomes very easy, right? 0. Alright, so here's what is going to happen. The graph has to come from up here, and it has to go up here, right? It's got to pass through this point, has to pass through this point, has to pass through, wait, that doesn't make sense. Oh. It doesn't have to pass through. What do you mean? It doesn't have to pass through. Well, look over here. Remember when I introduced these multiplicities? I'm going to make them yellow. And we're going to say this. Even multiplicities do not pass through. we're gonna color that one yellow. So it's gonna be yellow dots. Odd multiplicities, I'm gonna make, that's a bad color, isn't it? Let's make them this color. Now notice that 3 and 1 are odd, but 1 is completely different. So we're going to do this guy in red. Okay, so which one had a multiplicity of 3? The 4, right? So that one's got to be that brown color. Hopefully I can find it again. Whatever. This color. That's not what I want. Darn it. This guy. And the 1, we had some reddish color, didn't we? Whatever, this color. Okay. And what I'm going to do here is I'm going to draw 3 different cases. So if it's even, I'm going to show what it does. What it's going to do is it's going to come in and it's going to bounce off. If it's odd, but not 1. Oh, why did I do that? If it's odd but not 1, what you're going to get is at this point, we'll call it whatever. We'll call this point A. Doesn't really matter. Label it anything you want. What it's going to do is, if it's odd, it's either going to come and it's going to like snake through at this point. So it's going to have this, like the cubic does. When you have the x cubed, remember how it went like this and it snaked? This is what it's going to do. And you know, you can really think about it that way, because look at what happens when it's odd, which well, I shouldn't even say it. I mean, it is odd. What happens when it's 1? You have this value and it runs straight through it. And that should make sense. I mean, remember back when we had x plus 2, x minus 2. So x plus 2 minus x minus 2. So it's x squared is its parent function. We have x's at positive 2 and negative 2. And what happens? It passes through at negative 4. Right? So if this is negative 4 here, passes through this point, passes through this point. Well, notice that if I did zeros, I would have a negative 2 and a 2. And if I did multiplicity of them, I would get 1 and 1, right? And then we know that the parent function is a parabola. It's x squared. X times x is x squared. So it has to come through here. Change up this color. And make it a little brighter than that. Has to come through here, and notice what it does. It passes straight through. Comes around and then goes straight through and off into infinity. Okay, so that's this straight through idea. When we have a cubic function, 1, 1, negative 1, 0, it kind of comes up and then snakes through and goes off. Okay, so important, I don't know, depends on how good you want to be. That's what it looks like. So back to this this function that we were working on here. All right. So here's our function. We labeled our multiplicities. We had an even multiplicity at negative 2. We know it has to come from up here, and it has to go, it's going to come down. Because the multiplicity is 2, it's going to bounce off. And I'm going to change the color on the graph so you can see what happens there. So it bounces off. The multiplicity on the 0, there's only 1. It's right there. So it's going to go straight through. And it's going to have to, where does it got to go? it's got to go through this point right here, right? So it's just going to start coming back up and off to infinity. Okay, so let's... Alright, so what I've done here is I've thrown this into this graphing calculator, and it's going to be the red one. And we'll click graph. Let me show that one. And that's interesting. It didn't want to graph it, so hang on 1 second. Alright, so I don't know if you can see it, but I put it into this calculator, and it took me a minute because I was trying to figure out, okay, look over here. When x is 0, y is 0, right? So it does go through this point. It's really hard to see. Now, looking at our graph, we said that this is kind of what it looks like, but in actuality, it does something really interesting. But again, like these are just sketches, so what it really does doesn't matter. So it comes off this value and it shoots way up here, and then it comes down and it rides this y-axis, and then it passes through here. Remember I said this cubic function makes it and you know what? I just realized something. It's 1, so it passes through here, and then looking at this graph, it goes way down here. See it right there? That red line? Anyway, again, complete difference from sketching and not sketching. So it actually comes down here, rides this line to somewhere, and then it comes up. And when it does, when it passes through here, it does that snaky thing. Right through there, that cubic function, that guy. Something like that is what that's supposed to look like. Okay. So let's see. I'm going to put a couple problems here and let you guys work them out. Alright, so there you go. There's your function. I just want to sketch with the graph. Go ahead and pause the video, go make a sketch of the graph, and when you come back, we'll go over it. Alright, welcome back. I'm going to go ahead and try to speed this up, and I'm going to pause the video while I'm recording, so that way you're going to start to see things popping up, and I won't go on without talking about them, but here we go. Alright, so zeros in multiplicity. So we have zeros at 4 and 2. Or 2 and 4, however you want to look at it. Multiplicity of 1 and 1, so we're going to have that straight through action. So we have a parent function, going to be x squared. The y-intercept is going to be -4 times -2, so positive 8. We have, I think we can go ahead and graph it. Alright, so we have our y-axis and x-axis, and we just pop in our zeros here. So we have a 0 at 4 and a 0 at 2, and our other guy at 8. So what is it going to do? The parabolic shape means that it's going to go over here and over here. So we come down, we go through 2, go down some point, come back up, and shoot off, something like that. So that would be my sketch of the graph. And for a parabola, remember that this point here is the vertex. And the vertex is equal to negative, let me write it down here. It's going to be the point negative b over 2a, comma, the f of negative b over 2a. So in order to figure out what this particular point is, right here, we would solve this. So let me do that real quick. Alright, so we have x squared minus 2x minus 4x plus 8. So this is x squared minus 6x plus 8. Okay, so b is equal to negative 6. So b is equal to negative 6. So it's the opposite of b, so it becomes a positive 6. And 2 times a, what was a? 1. Yep, 1. So this is going to be over 2. This is going to be 3, comma, and then the f of 3, which that is going to be the f of 3 is equal to 3 squared minus 6 times 3 plus 8. That's going to be 9 minus 18 plus 8. Okay, so minus 8 plus 8, negative 10 plus 9 is negative 1. So 3 comma negative 1. And if you look, this vertex, there's one more thing that we could add to parabolic, but again, we're not we're just sketching, but I mean, why not throw in a little bit about the vertex? So this is the vertex, and notice that this is point 3 comma negative 1. So in all actuality, I think my sketch was pretty close there. So let's go back to the original function. Right, we'll just use this right here. So we have x squared minus 6x plus 8. So we have x squared minus 6x plus 8. And we'll click graph. Oh, look at that. Parabolic. Our vertex. So add negative 3, 3 comma negative 1. This parabolic shape off to infinity. And I'll zoom out a little more. You can see that it crosses the x-axis at the point 8. So yeah, if this is what you got as far as your shape goes, good job. Alright, forgot to add that closed bracket there. Alright, let's see. Let's do another one. Okay, I'm going to put another function up here and let you guys try this one. Alright, we'll call this one g of x equals x to the 5th plus x squared plus x minus 5. Go ahead and try that one. See what you come up with. I just realized that this one is going to be, it's going to require a whole lot more algebra. So let me make this a little simpler. Actually, we could probably keep that, but what we're going to do is we're going to add another term here. Let's do that, and go ahead and try it and see what happens. Alright, so you should have simplified this thing as g of x equals x to the 5th plus, these are the same, so this would be 2x squared minus 5x squared. And then when you simplify that a little more, you get g of x is equal to, notice that there's an x squared common to everything, so I'm going to pull out an x squared. So I get x to the 5th plus 2 minus 5. I'm sorry, this is an x to the 5th. If you caught that, that's good. Minus 5. And that's going to simplify even further. So we have x squared times x cubed minus 3. And if I was smart, I would have went back up here and changed this up to make this value 8. But I'm not. So here we go. So we're going to factor this x cubed minus 3. This one's going to be interesting. And as I suspected, it's not factorable using real numbers, so my apologies. I'm going to go back up here and I'm going to change some things to make this turn into an 8. Alright, so if we go in here and we change some things, I'm going to change all of these. Again, I just came over this off the top of my head, so my apologies. So that'll be minus 8. Okay. So now what we can do is we can use the perfect cubed formula here. So we're going to get x minus 2 times x squared plus this value times this value. And just realize that if you don't know the formula for it, that would be x squared. To factor a perfect cube, it's going to be, you take the cube of this guy, the cube root of it, which is going to be x minus cube root of that is 2, right, which was what we had here. Or let's look at it in this form. So x minus a equals x squared plus ab plus a squared. So this is going to be x squared plus 2x plus 2 squared. Alright. And now we can factor this a little further. So we get x squared times x minus 2 times x squared plus 2x plus 4. This guy is the guy that we're going to factor more. This becomes x plus 2 times x plus 2. So now, when we're looking at our zeros are going to be, we have a 0 at 0 right here, a 0 at 2, and a 0 at negative 2, with a multiplicity of, there's 2 zeros, there is 1 2, and there are 2x plus 2, so there's 2 negative 2's. So now if we wanted to graph this guy, alright, I had to move some stuff around here. Okay, so this was our original function, x to the 5th. So the parent function is x cubed, and it's an odd function. And our zeros were negative 2, 0, and 2. So remember, the parent graph looks like that guy. Again, we don't care what happens in the middle. So let's put our axis here. So we have x and y. got to get a y-intercept. So when x is 0, y is, well, 0. So it's going to be right there. Our x-intercepts are at -2, 0, and 2. And we'll grab a different color here. We know that it's going to look like this, so it's going to have to come in from here and exit through here. Let's put those zeros here. Okay, so it's going to come up to 2, and then looking at 2, it has a multiplicity of 2, so it's going to bounce off and come back down. How far down? I don't know. It's going to got to go through this point here, so it's got to come up and go through 0. And then I apologize. At -2, it had a multiplicity of 2, so it's going to bounce off. At 0, it has a multiplicity of 1, so we're going straight through. At 2, it has a multiplicity of 2, and it's going to bounce off again. So something like that. And this would be a sketch of this graph here. Again, I'm sorry for the confusion, and I'll try to better plan next time. Let's see. We've done parabolic, we've done cubic. Alright, so real quick, let's run through a couple more. Okay, so f of x is equal to x plus 3 times x minus 4 times x plus 1. Alright, go ahead and graph that one, and we'll go over it when you get back. Hopefully you went and graphed this, sketched it. If not, remember, it's not a spectator sport. So we have x and y. We have x is at -3. We have an x at +4. We have an x at -1. And we have a y-intercept at 3 times -4, so that's -12 times 1 is -12. So down here at -12. We have a different color here, so there's our zeros. The parent function is going to be cubed, so x cubed, so I know that it's going to start here and go up through there. All the multiplicities, the multiplicity here is 1, 1, and 1, so it's going to go straight through everywhere. So it's got to go from here, through here, through here, through there, and off into infinity. So that's a rough sketch of what that would look like. Let's go ahead and do another one. Alright, how about this one? F of x is equal to x to the 4th minus 6x squared. Go ahead and take a moment to sketch that graph, and we'll go over it in a minute. Alright, welcome back. Let's go ahead and go over this one. So we have a x-axis and y-axis. This all becomes repetitive at some point. I'm going to need to do some algebraic manipulation here. I'm going to pull out an x squared. So this is equal to x squared times x squared minus 6. Alright, so I need to get my zeros. So I need to work with this guy. Alright, so we have x squared minus 6 equals 0. That's x squared equals positive 6. So we take the square root of both sides, and we get x is equal to plus or minus the square root of 6. And our other 0 is x squared. So our zeros for this guy are going to be 0 with a multiplicity of 2. Remember, it's squared, so we have a multiplicity of 2. And then it's going to be positive root 6 or a negative root 6. A multiplicity of 1 and 1. And what I'm going to do here is I'm going to go to my calculator and I'm going to take the square root of 6. So it's 2.45 approximately. So we go back to our thing here. So approximately positive 2.45 or approximately negative 2.45. Alright, so this is 1, this is 2, this is 3, this would be about in the middle, so we'll say that that 0 is right about there. And we have negative 1, negative 2, negative 3. So this is about half, so right about there, right about there, and then it goes through 0. The parent function is going to be x squared, right? So it's going to have this parabolic shape, which means that it, no matter what, doesn't care what it does in the middle, it's going to go off to infinity and positive. So here we go. So we're going to come from here. What was our multiplicity? At negative 2.45, it's 1. So we're coming straight through here. Come up to 0. At 0 we had a multiplicity of 2. So it's going to bounce off. And then we had a multiplicity of 1. Oh, my bad. Comes through here and something like that. Now I do want to point out that this is a sketch, but to be honest, this and this should look about the same. So I'm going to try to make this look a little bit better. Something like that. Alright, pause this thing and come up with another one. Alright, we're back with x cubed plus 4x squared minus 7x. Alright, take a minute to go ahead and graph this one, and we'll go over it in a minute. Alright, so our, let's see, we need to pull out an x. So let's start with this equal to x times x squared plus 4x minus 7. Alright, so I need to factor this guy, and you guys might actually be better than I am with the factoring. The way that I do it is I draw a little table, and I have to have two numbers when multiplied together give me this negative 7 and a positive 4. They're different, the signs are different, so one's got to be positive, one's got to be negative. So here we go. So what is 1 and 7? What's that give me? A negative 6? That doesn't work. Interesting. So it fails that way, so what I need to do now is use the quadratic formula to come up with this answer. So we have negative b plus or minus the square root of b squared minus 4ac all over 2a. A equals b equals c equals. My a term is 1. My b term here is 4. And my c term is negative 7. My constant term. Alright, so let's see. So the opposite of b would be negative 4 plus or minus the square root of 4 squared minus 4 times a times c, negative 7, divided by 2 times 1. Alright, so now we have negative 4 plus or minus the square root of, this is going to be 16 minus what? Or plus maybe, looks like plus. Negative 4 times negative 7 is a positive 28. So this becomes plus 28. Sorry, my pen was acting up. And we're going to divide that by 2. Alright, so 16 and 28. Alright. I mean, I could do this by hand, but whatever. So we got 44, and now I'm going to want to take the square root of that guy. That's going to be 6 point blah blah blah. So we have this guy plus negative 4 plus, actually, so minus 4, divide that by, whoop. I don't know how to undo it. I gotta start over, hang on. Alright, so we have take that number and divide it by 2. So 5.32. And our other number is going to be 4 minus the square root of 44. And take that and divide that by 2. We get negative 1.32. Alright, these are approximate answers. So, and we're doing a sketch, so it really doesn't matter. And then 0. So these are our zeros. And multiplicity of 1, 1, and 1. So we know that it's going to go straight through. At all of those points, let's go with the parent function, x cubed. So the parent function is x cubed. So x cubed. So we know that it's going to do this. Don't care what it does in the middle. So we have a 5, 3, 2. Whatever, we'll say that about right there. We'll call that 6. Negative 1.32. So this would be negative 1, negative 2, and then a 0 at 0. Actually, I'll change these colors to make them a little brighter. Alright, and we said that our function has to come from here and go off to here, and it goes straight through. So we come straight through that point, straight through this point, straight to that point. And that's about what it looks like. Label this, call it a day. I'm going to plug this into that graphing calculator just to make sure that my math was right, everything worked out the way it was supposed to. I don't want to be giving out misinformation. X cubed plus 4x squared minus 7x. Alright, do you remember when I said I didn't want to be giving out this information? I'm glad I looked at it because it's close, but I messed up. I messed up when my little calculator had a meltdown. Alright, so let's go back up here. You see these zeros? This one's positive, this one is negative. If we look at the calculator, let's pull up this calculator. You see right here, I took 4, and I did it in the other case too, instead of negative 4. And that's my apologies. And if we scroll up here, we can see that it was in fact negative 4. Okay, so this graph is going to look a little bit different. Yet the same, right? And hopefully some of you guys caught my error early on. Okay, so we have negative 5. Call that 6. Call that negative 5.32. That's 0. This 1. And I'll call this 2. We'll say it's about right there. So we have these pretty little zeros here. And we have a y-intercept, which I guess I should have talked about that. I didn't. The y-intercept is going to be at 0. Right there. Okay, so again, it's the same deal from here to here and through these points. Interesting enough, this graph looks just like the one that we just did. Okay, so technically I probably could have just changed the values, but it would have looked a little cattywampus. Alright, so let's look at the graph, what it's really supposed to look like, and we can see. There it is. Again, ours, you know, if we're looking at our graph, this right here, on the actual graph is way up here. But we don't need to concern ourselves with this. We don't care. I mean, most teachers don't care. I mean, if they haven't taught you how to find that point, then they probably don't care. It's going to be a sketch. Alright, so real quick before I end this video, one of the really fun things to do is to, when you test your knowledge of everything that we've learned, basically what you should be able to do is to build a function from a graph. So if I said that I had a 0 here, here, and here, and we'll call this point 1 and this point 2, roughly. And actually, let's move this point over just a little bit. Supposed to have some paint, aren't I? Let's move that point over. Equidistant. So we'll say right here. And actually, let's change this. So there is no 0 there. Let's put the 0. Let's call this 1. And we'll put the 0 here. Okay. Now, I'm going to do this. I don't know if you heard that. My wife just called me. I'll be right back. Alright, sorry about that. Okay, so what I would like you to do, now again, this is just like a sketch of some weird graph. I want you to tell me what the function is. Like, f of x is equal to stuff. What's this stuff? And I'll go over it in a second. Alright. Hopefully you took the time to do that. So this stuff will no longer be stuff. We're actually going to call it something. Okay, so let's think about this. Let's label these zeros. Okay, so this would be, that was supposed to be negative. I don't know if you call it that. -3, and this guy is going to be 2, roughly. So I'm going to have zeros at x plus 3, zeros at 0, and I'm going to have zeros at x minus 2. Alright, so let me clean this up. So x times x plus 3 times x minus 2. But, now looking at this, that's not right. That can't be right because the parent function here is cubic. So what did I forget? Because if it was cubic, it would come from down here and go up here, right? Oh, I see. What about this? What did we say about this? When it does this, what is that? Multiplicity, right? So this has to have an even multiplicity. So I'm just going to pick 2. I guess it could have been 4. It could have been 6. Could have been, you know, pretty much whatever. Probably not. Probably 2, 4, maybe even 6 might have gotten you there. But okay, so we have a multiplicity there as well. So, but now let's think about this. Oh, you know what? I don't know what the heck I was thinking, but there isn't a 0 at 0 anymore. Remember, we took that out. This point is 2, right? So when all this is 0, this has to be 2. Okay. So this is going to be 3 squared times -2 squared. So this is going to be 9 times 4. That's 36. Now I need it to be 2, right? When all those x's are 0, I need this to be 2. So, okay. So 36 minus what is going to give me 2. So, alright, so we subtract 36 from both sides. We get negative n as you get. I know that you probably already know this answer, but I'm going to get somebody to comment on the video that's like, how did you get that? So I'm just going over it. So we have a -34 divided by -1. Those cancel. Divided by -1 and equals 34. Okay, so we're going to have to subtract 34 from this, and then when x is 0, I'm going to get 9 times 4 is 36 minus 34 equals 2. Which would be my y-intercept. So I'm thinking, and if I did it wrong, you come up with a different answer or whatever, just leave me a comment. But I think that's right. Alright, so we're going to do one more thing here. that. We'll do this, and we're going to do that. I want you to tell me what the parent function is for these functions. Alright, hopefully you took the time to do that. The parent function for this guy is x cubed. The parent function for this guy, and we didn't talk about it in this video. I probably should have, but I didn't, and that's kind of why I wanted to include it here, you know, at the end. We always talked about this thing of going from negative infinity, positive infinity, parent function, you know, how something happening here and it doing this, right? Well, this guy is the reflection of that guy. So this is going to be the negative version of it. So the parent function is x cubed, but it's the negative. Notice that this one does something in the middle, comes from here and goes here, like that. This guy, in the same respect, x squared looks like this, right? This guy is upside down, so the parent function would be negative x squared. And